Hey, y'all. I am so excited to be joining you from the US and to be helping close out this amazing NDC Porto conference. And thank you for joining my session. I hope you're doing well and staying safe. Hello, I'm in recovery for type coercion and automatic semicolon insertion, and my name is David. Maybe you're like me and you've been burned a time or two by JavaScript, burned in development and in production. Well, JavaScript has caused many a developer more than a fair share of indigestion over the years. My first introduction to JavaScript was around 1997. At that time, I was a Visual Basic developer, and I started building web apps with ASP, active server pages. What we would now refer to as classic ASP. And I kept reading about people doing this thing called dynamic HTML. And I wanted to learn how to make my websites more dynamic. Dynamic cursors, alert boxes, rollover buttons, objects that bounce around on the screen. The more obnoxious, the better. Am I right? Well, my career really started to take off and get serious as a web developer around the .com bomb in the early 2000s. I joined a hot startup to build an interactive commercial web app, and I needed to support both Internet Explorer and Netscape. It seemed like so many cool companies were having great success with JavaScript. I wanted to be a cool developer, but it sure was a struggle to learn, and there was a lot of trial and error. With JavaScript, anything goes, and it often does. If you were a web developer around this time, you probably remember sites like Dynamic Drive. I spent countless hours trying to understand the JavaScript code I lifted from sites like Dynamic Drive, and it worked on their websites, the examples and everything, but when I pasted the exact same code into my app, it didn't work, and I couldn't figure out why. JavaScript is amazing, except when it isn't. There's quirks and weirdness in the JavaScript language that continue to exist even to this day. Unexpected behavior can baffle even the most seasoned JavaScript developer. Let's take a look at a few of those examples of that quirky behavior. JavaScript has a special value named nan, N-A-N, which stands for not a number, which is not to be confused with null or undefined. So given this statement, if the variable f is not a number, is nan, then the entire operation of the result will be nan, which can lead to lots of fun time. Sometimes it's very difficult to find where the nan is occurring in your code. And it's, maybe you're looking for some clues. So how can we test in our code for nan? It's not a number, but what's the underlying value of nan? What can we test for? Is nan greater than or equal to 0? No. Is it less than or equal to 0? No. What's the type of the nan object? It's a number. Gee, thanks a lot, JavaScript, for making our lives so easy to use this tool. In math, we have something we call commutative properties. So mathematically true, if we take a plus b and these are equal statements, right? Order of operations and everything. In JavaScript, when we evaluate this type of statement, it's not always predictable. There's cases where it's true and there's cases where it can be false. So if we were to say, is this code true or false? No, it doesn't always equal true. If we try to look at, is 0.1 plus 0.2 equal to 0.3? No, it's not. What? What is 0.1 plus 0.2 in JavaScript? It's 0.3 something. This is not just a JavaScript problem. This is floating math, floating point math, and for computers is hard, apparently. Seems like we're smart people. We should be able to figure these things out. But this is the kind of stuff that we still have to deal with. Here's an example. If we round this gigantic number, we get 0, as we would expect. It's less than 0.5, so it's going to round down to 0. However, if we round this very long number, and if you notice, the only thing that changes between the two numbers is the very last place, from 2 to 3. If we round this number in JavaScript, we get 1. Fantastic. I've got 99 problems, but JavaScript ain't 1.00000000009. Let's talk about sorting in JavaScript. If we were to sort this array of 2 and 10, we would get 10 and 2 as we would expect, because JavaScript is being really helpful in ignoring the fact that these are numbers, not instead of strings. If we map things like an array of strings and we want to parse these numbers, we would expect an array of tens, right? No, we get something silly like this. Thanks, JavaScript. And then, there are types inside JavaScript, and there's this type of operator that helps us to determine what these types are. So if we say, what's the type of undefined? It's undefined. Type of true, that's a Boolean. Type of string, it's a string. So far, so good. Type of 1 is a number. But if we say type of an object, well, it's an object. That's great. If we say type of an array, it's an object. Type of null, it's an object. The black art of figuring out the type of variables, I don't know. Good luck. And then we've got things like, we've got this helpful operator called number. Number is supposed to convert things over to the numeric values of these things. So if we take null and pass it to number, on the other end, we get 0. So null must be 0, right? It must be equal to 0. No. No. Is null greater than 0? No. Is null less than 0? No. Is null greater than or equal to 0? This one is true. I have no idea. Less than or equal to 0 is true. Well, it's not 0, but it's somewhere. I don't know. And then we've got these weird concepts in the JavaScript language like falsy, truthy, and falsy values. False, null is considered to be a falsy value. Undefined is falsy. Empty string can be equal to false. 0 is false. Nan can be false. Yeah, good luck. And then there's things like, powerful features in the JavaScript language like regular expressions. I have a problem, I'll solve it with a regular expression. Now I've got NaN problems. So we take something like this, we have WAT equal to this regular expression of A. We want to test the string JavaScript, and yes, there is an A in JavaScript. And then we test, we turn around and we test another string, and that's false. Uh, what? Well, it turns out that the regular expression object itself maintains state, and so the index changed out from underneath us. That's can be really helpful and hard to easy to figure out. And then we got some syntax quirks, like, we've got this function. We want to return an object. And what should this troll return when we call this function? It returns undefined. What? I thought we were returning an object. Well, JavaScript tries to be really helpful, and there's no, syntax matters. And so it sees this return statement with nothing else after it and thinks, oh, well, I need to insert a semicolon here. Thanks, JavaScript. Let's talk about arrays. Arrays are dynamic in JavaScript. That's pretty cool. You can just start stuffing things into arrays. Like if we want to index 1 and change that value to 1, or index 3 and get that a value of 2, we can willy-nilly add things to an array. And when we're done, we can take array.length to figure out how many items are in our array. And we get 11 items in our array. This almost makes sense, right? Maybe. But we can do some weird things with arrays too. We can index -1. We can say array.s. We can start just willy-nilly adding properties to our array. And when we take array.length, now what's our length now? It's still 11. Why? JavaScript has been around for years, and we're smart people, right? Why haven't we fixed these things? How did this happen? JavaScript, arguably the most popular, most ubiquitous, most universal, most pervasive language in computer science history so far. If it's so important, why is it so terrible at times? Well, let's look back at the birth of JavaScript. It's a classic example of how so many things get created in software. And it's funny, but it's the kind of funny that makes you want to cry. This is Mark Andreessen. He was at the University of Illinois and was one of the people who created the very first internet browser, the NCSA Mosaic. Mark later moved to Silicon Valley, and he helped start a little company named Netscape. In February of 1995, Mark hires a man named Brandon Ike. Brandon was hired to create a scripting language for Netscape. The original plan was to implement Scheme, a dialect of Lisp. In May of 1995, Andreessen calls in Brendan and says, "Brindlepants, we need a demo of that new scripting language, like yesterday." "It's Brendan, sir. Sure thing. Scheme in Netscape is going to be awesome." Brandy Farm, you're hilarious. Scheme in the browser. Oh, man, you got me going there. But seriously, though, it's got to look like Java. Let's call it Mocha. Mocha, Java, get it? And we need a demo by the end of next week. People aren't convinced that this thing is going to fly. I'm going to need you to come in on Saturday, okay? And Sunday, too. So, what does Brendan do? He does what any of us would do in this situation. He works like a heroic machine through the nights, and 10 whole days later, he delivers Mocha. The first version of JavaScript was created in 10 days. That's both incredibly amazing and absolutely horrifying. Good work, Boogaloo. Ship it. But sir, it's only a demo. I still need to ship it. It's the most classic move in all programming. Ship it. Mocha was supposed to be for amateurs and designers anyway. Who cares if it's buggy? The real professionals are going to use Java. Java is the future. Plot twist, Java. It was supposed to be the language for the web, for the browser. And we know how that played out. Java, the applets, remember, write once, fail everywhere. Well, I think it's interesting to look at some of the other things on the timeline during the early days of JavaScript. After Mocha is created in 10 days, it goes through a couple of iterations. I mean, the code itself doesn't really change, but it goes through a couple of names. It got renamed to LiveScript for a little while, and then JavaScript in December of 95, Netscape releases, I think it was version 2, beta 1 or something like that, that includes JavaScript. Well, Microsoft takes notice and they see this cool new scripting language that's in Netscape, and they decide to reverse engineer what Netscape has done. But if you remember this, if you're around this time, they didn't call it JavaScript. JavaScript is trademarked by Sun, so they called theirs JScript. Well, Microsoft did such a good job of reverse engineering that they reverse engineered everything down to the littlest detail, including all the quirks and things that JavaScript did weird. Now, this prompted Netscape to go on the defense. So Netscape is seeing how Microsoft worked, at least around this time in history. Microsoft's classic strategy of embracing, extending, and extinguishing technology, right? Netscape knows if Microsoft has their way, they'll run away with the language and ultimately destroy it or replace it with something else, or who knows how that may have turned out. So in an offensive move against Microsoft, Netscape decides to standardize the JavaScript language. So they went and talked to the obvious candidate for the standardization, the W3C. And the W3C responds with, oh, well, no thanks. We have more important things to focus on, like marquee and the blink tag. Well, thanks, W3C. Keep up the good work. We'll move on. So Netscape approaches ECMA International, which is a standards-based organization in Sweden. And ECMA takes on the project, and they form what's called the TC39. This is the Technical Steering Committee for the JavaScript language. And eventually, after a little while of work, the TC39 creates a document called ECMA 262. ECMA 262 is what we have. It's what continues to evolve to this day. It is the formal language spec for the JavaScript language. Now, the reason it's called ECMA, and we hear this strange word used a lot. JavaScript, again, at this time, and still is to this day, although it's arguably unenforceable, JavaScript is a trademark of Sun, and they couldn't use JavaScript as the name of the language in the spec. So they named it ECMAScript. This is where ECMAScript comes from. ECMAScript is the language specification. JavaScript, as we find in the browsers, is just one of several implementations of that standard. So you know, fast forward a little bit, ECMA releases ES2 in 1998. It's basically just some updates for ISO certification. And then we get ES3 in 99, which includes some things like regex, try catch, and some better string handling. Now, moving forward in time, we look at ES5, adds strict mode and reduces some of the quirkiness of the language. There's JSON library support added. And ES6 is a major update, adding classes and generators and arrow functions, promises, and many more features. But wait, hang on a second. What the crap? 10 years between ES3 and ES5? Man, if you were a web developer during these years, that's a long time to wait. And it was a real struggle, right, to build web applications using ES3 until ES5 came along. So what happened here? Well, Microsoft won the first browser wars with IE6 around 2001, and basically they sat back to watch the world burn. Microsoft won, but we as web developers lost. By 2008, now, ES4 was being worked on, and by 2008, ES4 was so big and so complex, and there was no consensus among the members of the standards committee. And for technical and political reasons, there was representatives from Microsoft and Yahoo and Adobe that were all part of the committee. So an important decision was made to abandon ES4, and they took some incremental changes that was slated for ES 3.1 and renamed it to ES5 and set the path forward. Well, there's an interesting side note here. If you remember during those days, Macromedia Flash was a plugin that once dominated the web. People created amazing interactive interfaces and games with this animation plugin. What you couldn't do with JavaScript, you solved with Flash. In Flash, if you were building anything more than maybe a cartoon, you needed to use its programming language called ActionScript, which looked a lot like JavaScript. That's because ActionScript was another implementation of the ECMAScript standard. So between 1999 and 2009, the developers at Flash were early implementers and adopters of the proposed ES4 spec, and they were helping to push the language forward. By 2006, ActionScript 3 had classes and interfaces. It had a type system. There were enums, default function parameters, modules, packages. It had a lot of great language features. Flash developers could argue that what they had in 2006 is still better than what we have in JavaScript today. Let's take a quick look at a few other major milestones of the web that helped to influence JavaScript over the years. In 2001, we talked about Internet Explorer 6 coming out, and that helped or hurt in some cases, set the JavaScript language for a long time. But around 2004, we see some tools like Firefox comes out, and there's a web developer tools that gets created for the Firefox browser, and Gmail comes out. Gmail, along with Google Maps, and took the browser apps to a whole new level, never thought possible. And they demonstrated to the world what the browser was capable of. And jQuery made a huge impact on web developers because it was for the, it wasn't the only library that did this, but this is, jQuery really took off in popularity. but it was, jQuery gave us a single API that normalized the differences between the browsers. jQuery and its popular plugin community made web application development accessible, taking away a lot of pain. Not all of the pain, but a lot of it. But web apps could be built by mere mortals like you and me with the help of jQuery. And then around 2008, Google Chrome comes along and it takes the web by storm. Microsoft has been coasting on IE6 for years, and people are desperate for a better browser. The Chrome adoption grows so quickly that it stirs Microsoft to start releasing new versions of IE. And in 2009, we get the ES5 Harmony, and around this time, Internet Explorer 8 comes out. And then, there's just for reference, there is a 15-year gap between HTML 4.1, CSS2, and then the release of HTML5. But that's a whole nother story. Let's go back to the TC39. There's 10 years between ES3 to ES5. And then there's another 6 years from ES5 to ES6. The TC39 knew that they needed to fix their process. But adding new features to the JavaScript language is not a trivial task. The first rule of the TC39 Fight Club is don't break the internet. Backwards compatibility has always been one of the highest priorities when making changes to the language, which is why some of the quirky behavior still exists. It continues to exist on purpose. It's codified in the spec because if they fixed it, it would break code all over the world that expects that weird, quirky behavior. The internet would collapse and the world would explode. I submit my hypothesis that the Death Star superweapon is actually a very powerful JavaScript emitter. I think that's right. The TC39 committee is made up of developers, implementers, framework authors, and academics. The ECMA 262 document is currently more than 1,200 pages. Since 2015, the TC39 has been on a better process, has had a better process in place, and they do things like they meet every 2 months, they meet for 3 days at a time, the discussions are time boxed, the entire process is open, and you can follow their progress through their repos and meeting notes. So everything's done out in the open. In order for a new idea for the JavaScript language to make it into the ECMAScript standard, that idea has to be moved through a series of stages. Stage 0 is the first stage, and of course, the TC39 process is a zero-based index. Bunch of nerds. Stage 0 is the idea stage, also known as the straw man stage. Lots of new ideas get submitted at stage 0. And then stage 1 is the proposal stage. There's an agreed upon first draft of this idea. A proposal essentially states what the problem is, how it might be solved, and some of the known technical challenges. A polyfill might be created as a proof of concept. And a polyfill is like a JavaScript library that demonstrates how this new idea might behave or look. At this time, a champion on the TC39 is selected to take ownership and to see this proposal through the rest of the stages. In stage 2, this is the formal spec stage. A specification draft is created. The syntax and semantics and backwards compatibility, all that, those kinds of details are fleshed out as part of the idea. And then stage 3 is called the candidate stage. The specification has been finished, and this is a signal to the rest of the world that they can start, trying to implement this new change in the specification and get real world usage and feedback. So at this time, browsers and other implementations of JavaScript or ECMAScript can choose to add this new feature. Usually it's behind a feature flag or a plugin or something like that so that people can test it. And this is where we see Chrome add new features to V8, which is the Chrome JavaScript engine, behind feature flags. You can turn those on or off. And in Node.js, which also uses Chrome V8 as its engine, those feature flags can be used like command line switches. Now, when something reaches stage 3, it's very close to being in the spec, but it's still no guarantee that this is going to make it into the final standard. There's enough feedback. If there's enough feedback that comes back to say this, this is not ready for production, this is not ready for the real world, then some proposals may never reach the next stage, or they may stay in that stage for a long time until it's finished. So when something gets to stage 4, it is finished. There are acceptance tests that are added to another project called Test 262, and there has to be at least 2 implementations that pass these acceptance tests. It's ready for the next release of the language spec, and a PR is created for the ECMA 262 document. Now, the cadence that the TC39 has been on since 2015 is the stage 4 candidates or selections are made in January of that year, and the new edition of the ECMA 262 document is released in June. And that means that we will soon have ES 2020. We've had ES 2015, 2016, 2017, 2018, 2019, and now we're at 2020. The decisions for ES 2020 have been made, and the latest features have made it to stage 4. Some are already available. The 2020 spec will be published in a couple of months. And if you're interested in knowing, there are several new features worth looking at. One is optional chaining. This is how we can, this feature allows us to safely access deeply nested properties in a JavaScript object. So imagine you have a JavaScript object like this one, and the address, some of the properties on the address, or maybe the address itself is optional. Of course, everything in JavaScript is optional, but you know what I'm saying. In the past, to access a property deep in the object, such as the city, you would have to test every property along the way to make sure it wasn't null or undefined. So optional chaining can express in one statement how to get access to an optional property, so that we don't have to test every single parent along the way. There's a new feature called nullish coalescing that allows you to test values that are specifically null or undefined. In the past, we've had this using the 2 pipes. We can say, is this thing falsy or not? And if anything that can be false, null, undefined, empty strings, 0, all those kinds of things, then you would get the default value. But if you only want to test null and undefined, you can now use double question marks to test for specifically null or undefined. One thing to note, if you're a Node.js developer, Node.js 14 was just released this past week, and it includes optional chaining and nullish coalescing because those are available in the newer versions of Chrome V8 JavaScript engine, which is what, as I mentioned before, it's what Node.js uses. There's also a global this, which is a consistent way of accessing the global object, regardless of your environment. So in the browser, there's the window object. In a web worker, there's the self object. And in Node.js, there's the global object. So now global this gives you one thing that you can use in case your modules or code is going to be used across multiple environments. There's a new promise.all settled, which is similar to promise.all, which we've had in the past. It takes an array of promises and it resolves when all those promises have finished. However, when using promise.all, if one of those promises is rejected, then it returns immediately and it's over. Promise.all settled waits until all the promises have returned, regardless if they are resolved or rejected. There's a new feature called dynamic imports, which allows us to dynamically import modules, and that import syntax is a promise that we can use either the promise syntax or use async and await. So in the second example here, we had a button listener click event, which means that that module, reporter.js, is only going to get loaded if someone clicks on the button for it. There's also a match all for regular expressions. Now, I can't go into the details for the sake of time, but trust me, this one statement, this one line, is saving a ton of code that you would have to do in order to do what this new match all function does now. And then there's a new data type called big int. And in the past, the largest integer value you could have in JavaScript was 2 to the 53rd power minus 1. That's a really big number, but it turns out we sometimes need numbers bigger than that. And so big int is now a native feature of the JavaScript language that allows us to deal with bigger integers, any really arbitrarily large integer. There's two ways to declare big ints. You can use the big int constructor, or you can use the letter N on the end of a number to signal to the JavaScript compiler or engine that this number is a big int value. Okay. Despite the weirdness and the warts of JavaScript, there are amazing things that continue to be created with the language. I mentioned this earlier, but applications like Google, Gmail, Google Maps, Google Sheets, these changed the landscape for web developers and help us to realize what we could do with the browsers and the JavaScript language. NASA is using Node.js to help analyze spacesuit data and to make astronauts more safe. JavaScript making astronauts more safe. It's a bold move, I have to admit, but that's what's being done. Atwood's law states that any application that can be written in JavaScript will eventually be written in JavaScript. And this self-fulfilling prophecy is no more true than things like emulators. There are entire operating systems that have been created using pure JavaScript. There's a DOS implementation, there's a Linux implementation, there's a Commodore 64 emulator, and God help us, there's Windows 95. There are so many things you can do with JavaScript, whether you need to or not. And there's things like Internet of Things with libraries like Johnny5 and Node-RED. You can do music using a tool like band.js. I have a personal project called Charter that takes chord charts in Chord Pro text format and turns them into beautifully formatted PDFs. JavaScript works great for doing things like that. There's games, and then there's desktop apps like Visual Studio Code, GitHub Desktop, and the Slack desktop app. Those are all examples of apps created with Electron, which is essentially Node.js and Chromium for the rendering. And that only just scratches the surface of what you can do with JavaScript. You can build really anything that you can think of that you can build with JavaScript, or build with a programming language. You could probably build it with JavaScript. May not always be the best choice for a given thing, but you can do it, and the power is there. JavaScript can be challenging, but it's getting better all the time. And I think the JavaScript language that we have today is far, far better than what we had years ago when we went through those years of ES3. And I find that JavaScript is now a joy to work with most of the time. Now, here are some of my thoughts on the future of JavaScript. In the life of JavaScript so far, we've seen the language evolve and be influenced by a number of other languages and libraries, browsers, and technologies. And in the past couple of years, TypeScript has gained a lot of momentum. TypeScript does seem to be becoming the standard for a type system for JavaScript. If you listen to the TypeScript believers, you might be convinced that it solves all the problems in JavaScript. I wouldn't go that far. Eric Elliott, a well-known author, speaker, and open source developer in the JavaScript community, he wrote a article called the TypeScript Tax. It's a cost-benefit analysis of using TypeScript based on his experience. Now, his experience can be different from other people's experience and is different. So it's the scenario of, well, it depends, right? But Eric Elliott makes the case that contrary to a lot of hype out there, TypeScript projects can introduce more friction instead of less friction. It can introduce more time, it can take more time to onboard new developers, and argues that a type system for JavaScript will only prevent a small percentage of bugs. The bigger, more costly bugs can't be prevented by a type system. It turns out, if you think about it, any language, a language that's dynamic or a language that's static, it doesn't matter, can't save you from making mistakes. I recently had a conversation with a developer who said 2 years of using TypeScript that he wishes his development team could go back to using plain JavaScript. So I've heard lots and lots of stories from both sides of the spectrum. TypeScript is great, can do a lot of great things. It can help you to move faster. It can help with large scale projects. It can help you to reduce friction when refactoring code, or it can also increase friction and cause frustration. It could be, just like the JavaScript language itself. Some of those things can be solved by education and experience and disciplines. Well, regardless, there are some benefits to TypeScript, and I see that TypeScript is continuing to have impact on the web developer community. I find it interesting that there are members of the TC39 who use TypeScript. And my prediction is that we may start to see the most valuable ideas in TypeScript begin to make their way into ECMAScript. And if that happens, will there continue to be a strong case for TypeScript? I look forward to a day when maybe we no longer need to use a tool like TypeScript. We have everything that we need in the Java, the pure JavaScript language. Regardless, I believe that there is a strong case for investing in JavaScript. The good, the power, the flexibility, the universality, it's everywhere. Those things, in my mind, far outweigh the negatives. The language, as I mentioned before, has improved tremendously in recent years, and I believe it's only going to get better. Thank you, JavaScript, for enriching our lives, for keeping us on our toes, and for making us humble when we're tempted to believe that we have it all figured out. I believe that all of us in technology have an incredible opportunity and a responsibility to make a positive impact on our workplaces, our community, and the world. I challenge you to take the things that you've been learning at NDC Porto, you share your experiences with others, and you help make our world a better place for everyone. Wherever you are, I hope you stay safe, you cherish the time that you have with your loved ones, you make the most of the gifts and the talents that you are blessed with, and you get out there and you be awesome. If you have any questions, please ask me on Slack and I will answer them the best I can. Thanks everyone, and I hope you have a great rest of your day.